Okay, we're back for part two. And just like what we did with the last lesson, we're going to take the same problem that we just did in part one, but we're going to change it just a little bit. And now we're going to make it a chapter 9 problem because we're going to run a test. It is recommended that teenagers get 8 hours of sleep a night. Mr. Cavell believes that his AP Stats students are getting less than that. To test his belief, he records the number of hours that 20 randomly selected AP Stats students slept last night. Do these data provide convincing evidence that the AP Stats students get less than 8 hours of sleep per night using alpha equals 0.05? So that's our significance level. Okay, so 5% significance level for that. So we start, now this time when we're running a test, our acronym is PHANTOM, so we're going to start with P and H. That's the first step. The parameter, again, is to say U is the true mean or average number of hours of sleep that Mr. Cavell's AP students get per night. Now the hypotheses, our null hypothesis is that mean is 8. That's the recommendation. That's where we're going to start from. The alternative hypothesis is what we think is really happening. Okay, the null hypothesis is what's supposed to happen, what the status quo is, where nothing has changed. But the alternative hypothesis is what we think is going to happen. And the alternative is that the true mean is actually less than 8 hours of sleep per night. Okay, so there's the P and the H. Now phantoms, then we do A and N. That's the assumptions, the conditions, and then we name the test. The assumptions, just like we did on the first part of this, random, yes, that's given. Now the 10% condition is not met because 20 students is not less than or equal to the total number of AP students that we have. We don't have 200. However, like we did for the confidence interval, let us assume independence, because that's what we're testing for. We need to have independence. That's why we're doing this. The reason we need random is we want to generalize this to that population. We cannot generalize this if the students are not randomly chosen. If we don't have independence, then unfortunately our standard deviation formula is not going to be accurate. So it's not going to be effective. But again, we're going to assume independence. And then for the large sample size, the central limit theorem, 20 is less than 30. It is not greater than or equal to 30. However, as we showed on the front, we don't have outliers, no outliers or heavy skew. The distribution is not heavily skewed for that. Okay, so we could draw that, and again, what it look like if we do it as a box plot. Yeah, you can tell from that. Okay, the median is a little bit more to the right, but not by much. Okay, so there's no outliers to that. It's not heavily skewed. So name the test. Well, this is going to be a one sample t-test because we don't know the true standard deviation. We don't know the population standard deviation. Okay, so we cannot use z for that, so we have to use t. All right, so let's see, P, H, A, N. So T and O is going to find the test statistic and then obtain the p-value. Now, on your formula sheet, the standardized test statistic, I'm making a video, but Jen Hamlet